Okay, good morning. So we have been discussing about numerical problems in the previous class. I think we discussed two numericals. Let's talk about the third problem today. Uh, the room air leaves an air conditioned space at 25 degrees Celsius and 50% RH. So again the condition is same, 25 degrees Celsius and RH is how much? 50%. Okay. The bypass factor of the cooling coil is 0. What it means, I have a cooling coil without any bypass factor. So X is equal to 0. Okay. The outdoor air is at 45 degrees Celsius and 30% humidity. So TO is equal to 45 degrees Celsius and 30% RH. The outdoor air quantity is 100 cmm. What it means? QV naught is given. How much is QV naught? 100 cmm is given as the value of QV naught. Okay. RSH and RLH are 200 kilowatt and 50 kilowatt. So RSH is 200 kilowatt and RLH is 50 kilowatt. Okay. And we need to determine the supply air state, mass flow rate of supply air. So supply air state, it means TS and WS, mass flow rate of supply air. So M dot S, and the state at the inlet of the cooling coil. So at the inlet of state of the cooling coil typically is state 1. So T1 and W1, and then we also need to calculate outside air sensible heat, outside air latent heat. Okay, and then room total heat RTH and OATH. So these are the things which are to be calculated. Okay. So have you understood? What we have is, we have some indoor condition which was there in the previous lecture as well. Then outdoor condition is also same. I think it is same, 30% and 45 degrees Celsius. And then bypass factor is 0. Okay. But what we are doing ventilation. And how much amount of air is ventilated? That is 100 cmm of air is ventilated. Okay. So all of you have psychometric charts. So you are going to the shop only today. Before how many days were there? 3-4 days. Okay, so tell me first the value for Wi. How much is Wi? Already we have calculated in the previous question. 0.0? 0.0099. W naught, WO, 45 degrees Celsius and 0.018278. Okay. Other than that, what conditions typically? Okay. Now what we can do? RTH I can easily calculate. 200 plus 50. It will be 250 kilowatt. Other than that, I can calculate RSHF. What will be RSHF? 200 by 200 plus 50. How much it is? 0.80. 0.80? Yes. Okay. Now, if you go to psychometric chart, what we have? I have O, outdoor condition. I have indoor condition I. Okay. Now my state 1, which is at the inlet to the cooling coil, that will be lying on any point in between O and I. Is this one clear? All are clear with this point? Important point is then RSHF is given in the question. So I can easily draw the RSHF line. Anyone is having any doubt about this? Can I draw RSHF line over here or not? I can draw RSHF. RSHF will be simply equal to what? Point 8 is there. So I can go to sensible heat factor scale. I can see the value of corresponding to 0.8, and then I can go to alignment circle, and parallel to that I can draw a line over here. So this will be my RSHF line. Is this point clear? Anyone is having any doubt about this? Please tell me. Okay. But RSHF line will not be helping us much now. Why? Why RSHF will not be helping much? Because we also have ventilation. Okay, so when we have ventilation, then outside air is also coming, and it is also coming participating in the process. So when outside air participate in the process, then ultimately what happens? The apparatus dew point temperature is decided by the grand sensible heat factor line. Is this one clear? The grand sensible heat factor line. But for knowing the grand sensible heat factor line, I must know the value of which point? I must know the value at state point 1, and I must know the values at state point 1, and I also must know what is the flow rate of the supply air. Is this point clear or not? If I don't know how much is the supply air, then I cannot calculate. Is this point clear or not? Okay. But one important thing is given in the question. What is given in the question? It is given in the question that bypass factor is 0. When bypass factor is 0, then the common solution of GSHF line and the RSHF line will be the supply state of the air. Is this point clear or not? And that must lie on the saturated state. That must lie on the saturated state, apparatus dew point temperature. So that's why I can extend this RSHF line up to the saturated state. All are clear with this point or not? So if I simply extend this line on the psychometric chart up to the saturated state, what I will be getting from here? Please tell me. This I will be getting the TADP, apparatus dew point temperature. And in present case, because bypass factor is 0, that's why apparatus dew point temperature will also be equal to T. Is this point clear or not? Now from psychometric chart, can you tell me what will be the value of TADP? TADP equal to T2. From this RSHF line, I will be getting equal to how much? Can you plot the angle as well? Near to 11. Yes, here value is 11.64 degrees Celsius. Okay, the value is 11.64 degrees Celsius. All are clear with this point, or anyone is having any doubt about this? Please tell me. What I have done, I have located the what? Dew point temperature. Once I located the dew point temperature, Can I draw GSHF line? No, because I don't know yet what is state 1. Okay, in between O and I, where is state 1? That I don't know. And moreover, at present I also don't know the value of grand sensible heat factor. If I know the value of grand sensible heat factor, that also I can pass through ADP and I can obtain the state 1. Okay, but I have certain parameter, additional parameter, which I can calculate now in order to determine the grand sensible heat factor. What is that parameter? Because TADP equal to T2, okay, it means that the supply state temperature is known to me. If I know the supply state temperature, can I calculate outside air sensible heat load? What is the formula for outside air sensible heat? 0.0204 QV naught T naught minus Ti. Okay, is this point clear? That is the formula for OASH. QV naught is given how much? 100 cmm. Okay. So if I substitute over here 100 cmm and this is 45, this is 25, how much I will be getting OASH? Tell me the value for OASH. 40.8 kilowatt. Can I calculate OALH? $50 into minus Wi. How much it is? W naught Wi we have already taken from the previous lecture. 41.77. 41.77. Now, if I know these two, already I know RSH and RLH. Can I calculate grand sensible heat? GSH. GSH is equal to RSH plus OASH. So 200 plus 40.8. 240.8 kilowatt. GLH will be equal to RLH 50 plus 41.77. So it comes out to be 91.77. If I have to calculate grand total heat GTH, it will be how much? Sum of these two, which comes out to be 332.57 kilowatt. Now what I can do, I can calculate grand sensible heat factor, GSHF. Okay, GSHF will be equal to GSH upon GTH, and if I do this calculation, what I am getting? GSHF is how much? 0.724. Is this point clear? Now, using this information, can I calculate state 1? Using this information, can I calculate state 1? Please tell me. GSHF is given to me 0.724. Now what I will do, on this scale, I will see 0.724 and then I will go to alignment circle. Say this is my alignment circle. I will draw a line in between alignment circle and this. Is this point clear? After that, I will use a parallel line which is passing through which point? ADP. I will draw a line parallel to this which must pass through ADP, because ADP is the supply state. So that is where our grand sensible heat line should meet. So if I know one point and slope, I can draw a parallel line. If I draw a parallel line to this, it will be crossing my straight line in between O and I at a point. That point will be 1. Is this point clear or not? Please tell me. Is this point clear or not? This is clear. So I have got state 1. This is the graphical way of estimating this. If I don't want to use graphical way, can I calculate it from the analytical formulation also? Graphically I have calculated state 1, but for this you have to draw in proper scale everything on the psychometric chart. Then only you will be able to use this graphical way. If you have to do it analytically, please tell me what is the way out? Not needed. RSH is given. If RSH is known to us, can I calculate the supply air volume? What is the formula? Please tell me. Very simple. RSH is equal to 0.0204 QVS into TI minus T supply. T supply is T2. I know T2, I know TI. Can I calculate QVS from here? Please tell me how much is QVS? Please tell me the value. $733.826. All of you can see this subject is very important. So for final year placement, one company has come and their job profile is on refrigeration and air conditioning, particularly on design of HVAC system. Is this one clear? So QVS is 733.826. All the questions are answered or not? Please tell me. All are answered. Any question left? Please tell me quickly. Tell me. Answered. All are answered. QVS is there, na? M dot S. If you have to calculate, how to calculate? Please tell me. If I have to calculate M dot S, M dot S must be equal to QVS upon specific volume of S. How to calculate specific volume of S? How to calculate from ideal gas equation? Please tell me. In the last lecture I have given you full derivation. What is specific volume? VAS is equal to RAT into 1 plus 1.60. Tell me. 78 WS upon P. This is the formula we derived in the previous lecture. Okay. So calculate VAS, how much it is. You have values for all WS. If you don't have the value for WS, you must be having, because you can calculate from psychometric chart. But let me give you the value if you have not calculated. It is 0.0085616. Okay. So this is the value of WS. All are clear with this point? So VAS comes out to be from here how much? This P will be ambient pressure 1 bar, okay, 101 kilopascal. So it comes out to be 0.8176 meter cube per kg. Clear? Now if you do so, m dot S comes out to be how much? 733.826 is cmm. So if you have to convert into per second, then divide by 60, divide by specific volume, and from here you will be getting MAS as 14.9586 kGa per second, kilogram air per second. Is this point clear? If you have to calculate how much amount of air is circulated, then how you can calculate? M dot AR, that must be equal to m dot S minus m dot naught A naught. Is this point clear? How to calculate m dot A naught? Rho naught into QV naught, rho naught into QV naught, okay, and or QV naught divided by V naught. What is V naught? T naught from here. If you calculate m dot A naught, it comes out to be how much? 1.79691. And m dot AR, if you calculate, it will be 13.1617 kGa per second. Okay, so this is the analytical way. Now if you have not used graphical way, you know all the masses, how much is recirculated, how much is this. Now just by doing energy balance you can calculate state 1. How? M dot AR is coming with which state? State I. Recirculated air comes from the room and it comes at state I, plus m dot A naught is coming with which state? H naught, and it becomes m dot S with state HS. Now you know HS, you know O, sorry, I have made a mistake. M dot S into H1, not HS, H1. You know H naught, HI and all the masses. Can you calculate H1? From H1 you can calculate T1 and W. Is this point clear? So this is how you can analytically calculate the state 1. Anyone is having any doubt about this? Shall we move ahead with the next question? Problem number 4. The room air leaves an air conditioned space at 25 degrees Celsius, 50% RH, same values. The bypass factor of the cooling coil is 1.5. New information is now bypass factor is 0.15. Okay, bypass factor is given as 0.15. The outdoor air is again 45 degree and 30% relative humidity. The outdoor air quantity is 120 cmm. What it means? QV naught is 120 cm. Okay, and RSH and RLH are 160 and 35. 160 kilowatt and RLH is 35 kilowatt. Okay. Now we need to determine ESHF, ADP. What is ESHF? effective room sensible heat factor, apparatus dew point temperature ADP, supply air state on ESHF, supply air state on ESHF. So let me explain to you this concept again. Supply air state on ESHF and actual supply air state. What is the difference between the two? Do you know? Actual air supply air state and then finally state at inlet of cooling oil. State at inlet of cooling coil OASH, OALH, OATH. And GTH. So these are the values you need to calculate. Okay. Do you recall the concept of effective room sensible heat factor, or shall I explain it again before going to numerical? Shall I explain it again? Same. So if you recall, this is something which I have drawn earlier. Okay. Now quickly let me explain to you one, two things so that you can understand the question well. So generally what we are doing, this is our cooling coil, okay, and this is the QS amount of air out of which QV naught is supplied to the ambient and QVR amount is recirculated, okay, and we need to match the supply air flow rate, so that's why QV naught amount we have taken from outdoor state, and this QVR recirculated is nothing but at the indoor condition R. Is this one clear? Now if I have finite value of bypass factor, what it means? Only some fraction of gas will pass through the cooling coil which will make perfect contact. Is this one clear? So the gas which is making the perfect contact, that is 1 minus x into QV naught and 1 minus x into QVR. So this is making perfect contact. And then I have two components. One is x into QV naught and other is x into QVR. X into QVR is simply getting first mixed with the cooled air coming from the cooling coil, and finally it is forming over here state 2 dash. Okay, and when to this 2 dash state x QV naught is mixed, then it forms state 2, the actual supply air state. So there is difference. One is supply air state on the ESHF line. So supply air state on ESHF line is 2 dash and actual air supply state is 2. Is this point clear? All are clear with this point or not? Now let us understand the one next aspect. Next aspect is X into QVR is the amount of air which has come from the room at TI state and it has just entered the room at TI state. So it means though this air is moving around, but at whatever state it has come, just at the same state it is entering in the room. So it means this X into QVR does not cause any additional load on the room. But if you see X into QV naught is the amount of air which has bypassed the cooling coil completely. Once it bypassed the cooling coil completely, its temperature is T naught and it is coming at T naught temperature and just entering into the room. So what it means? It means that X into Q naught amount of heat is something which is not cooled in the cooling coil and it has this much amount of air has just directly entered into the room at the outdoor conditions. What it means? It means that effectively it is increasing the sensible heat as well as the latent heat load of the room. Okay, so that's why we define effective sensible heat nothing but equal to room sensible heat plus X times of OASH. Because X times of OASH is because of the system design simply entering into the system. So it is effectively causing additional load on the cooling coil. Is this point clear? In the similar way, effective latent heat load on the room, effective RSH and effective RLH will be equal to RLH plus X times OALH. Point is clear? Now if you go to the diagram, of course that we will discuss while solving the problem, but just tell me one quick thing. State O, state I. Okay. In between these two, I must have state 1. And from state I will be having one line which will be representing RSHF. And from state I, again I will be having one more line which will be representing ESHF. Okay. And the characteristic of ESHF line is that it crosses the saturated curve at ADP. What it means? My GSHF and ESHF will be meeting the saturated curve at the common point, which will be my apparatus dew point temperature. Is this point clear? And we also know that the common solution of RSHF and GSHF represents nothing but my actual supply state 2. Okay. If I extend this GSHF 1 to, sorry, now if I extend one more line over here, starting from O to 2, that O to 2 crosses the RSHF line at a point which is called as the 2 dash point, and it is known as the commensurate supply air state on the ESHF line. Is this point clear or not? This is some additional thing which will be coming into picture. Okay. And what is the benefit of ESHF line? Once we are bringing the ESHF line, it is allowing us to calculate the supply state and the mixing state 1. If this factor is not known, then ultimately what would have happened? I would have first used some value of QBS corresponding to which I will be getting some supply state 1. Then I would have created the GSHF line, and then from the GSHF line I would have got some value of bypass factor, and then I had to iteratively check if that bypass factor is satisfying the given bypass factor or not. Okay, again how? Let's do the numbers, then it will be more clear to you. Okay, how I can proceed for the solution of this question? Tell me. I know from previous example what is Wi and W naught. Please tell me. Do I know from previous example what are Wi or W naught? I am not writing over here. I am simply writing Wi and W naught are known to me. Okay. And can I calculate OASH and OALH? How much will be OASH? 48.96 kilowatt. Those who have not calculated, for them I am giving formula 0.0204 QV naught into T naught minus TI. OALH 50 QV naught into WO minus WI. How much is value? 50.268. 50.123 is my answer. Okay, correct, no issue. Okay, from here what I can do now? Can I calculate ESHF? ESHF will be nothing but RSH. First I need to, ESH. First I need to calculate ERSH, effective room sensible heat. Effective room sensible heat will be RSH plus X times of, how much it is, please tell me. 160.34 kilowatt. Okay. Effective room latent heat, how much will be it? RLH plus X times OA, 42.5. Can I calculate effective room SHF? ERSHF will be ERSH which is how much? 0.79. 0.797, correct. Okay. Now you tell me what to do next. What I can do next, please tell me. Let's consider this is my state O, this is my state I. I must have supply state, this mixing state before cooling coil on straight line joining O and I. Okay. What I am having? I am having ESHF. Okay. What I can do? From the sensible heat factor, I can mark over here the value of ESHF. I can go to alignment circle. I can draw a straight line between ESHF and alignment circle, and then I can draw a parallel line to this, which must pass through which point? Point I. Okay. And this parallel line, when it will be striking saturated curve, what it will be giving me? It will be giving me TADP. So I have come to know TADP. All are clear with this point? What is the value of TADP? Please tell me, those who have plotted the line. Correct. 11.59. Point is clear. So we can calculate ADP. ADP is calculated. What should be my next step? When I explained you the previous concept, I told you one very interesting point. You see, T2 dash is what? T2 dash is actual supply air state on the ERSHF line. What it means? It means that if this is ADP, this is actual state, then it means that this must be my bypass factor and this must be 1 minus bypass factor. Clear or not? Is this one clear or not? Okay. If this is the scenario, I can write that X is equal to T2 dash minus TADP divided by TI minus T. Can I write this? From the ERSHF line, I can write X is equal to T2 dash minus TADP upon TI minus TADP. From here, can I calculate T2 dash? How much is T2 dash? 13.6. 13.60, yes. Can I calculate W2 dash? In the similar way, X will be equal to W2 dash minus WADP upon WI minus WADP. Okay, you require WADP for this. I think WADP is 0. That is right. So that value is 0.0085327. WADP is how much? 0.0085 327. If you calculate W2 dash, how much it comes out? It comes out to be 0.00 87414. Okay. Are you able to follow on the diagram? Have you got how I have calculated this? Okay. What next I can do? If I know W2 dash, can I calculate QVR? Sorry, QVS? See, I know how much is effective room sensible heat. Okay. And ERSH must be equal to 0.0204 into, tell me the values, TI room condition fixed and supply state is what? T2 dash. Okay. So this is ERSHF line and this is some supply state 2 dash which I have calculated. So if I know this, then simply the effective load will be equal to TI minus T2 dash. How much is QVS? 611.717 cmm? No. 719.668. Did you take 45? Okay. Now I know QV naught. So what will be QVR? QVS minus QV naught. How much is QVR then? How much is QVR? 599.668. Clear? Okay. Can I calculate now supply state 2? Go back to the previous figure. Schematic. What I explained you in this schematic. If I know state 2 dash, then what is the flow rate at T2 dash? Please see. 1 minus x QVR is coming from here. X QVR is coming from here. So it means at state 2 dash flow is QVR plus 1 minus x into QV naught. So QVR plus 1 minus x into QV naught is coming at state 2 and x into QV naught is coming at state T naught. That is mixing to form entire volume at state 2. From here I can calculate state 2, the actual supply air state. So from the energy balance, from the schematic diagram I can write QVR plus 1 minus x into QV naught. Let me assume that density and Cp are same. So if density and Cp are same, then this volumetric flow rate is coming at state T2 dash plus x into QV naught is coming at which state? T naught. Finally it is forming the volume QV naught plus QVR, which is QVS, and it is becoming state 2. Can you calculate T2 from here? How much is T2? If you calculate, T2 comes out to be how much? 14 point. So this is the value for T2. Okay. Now can you calculate RSH? Sorry, everything we have calculated. Yeah, T2 also. Now only thing is left is, what is left? What is left? State at inlet of cooling coil. At inlet of cooling coil, what is happening? QVR is coming at temperature Ti, QV naught is coming at temperature T naught. It is forming entire thing as QVS with state 1. Is this point clear or not? Inlet of cooling coil. What typically happens? Recirculated air comes at temperature Ti, QVR into Ti, QV naught comes at T naught, both first mix together. Once these mix together, these lead to state entire volume QVS with state 1. Okay. How much is T1? Please tell me quickly. You have to calculate and tell me the value. $28.2476, correct. Now can you calculate other remaining things? Degree. Because whenever we calculated the enthalpy, 0 degree Celsius was considered the reference state. Okay, if you recall whenever we just started the introduction to psychometry, okay, reference state we defined 0 degrees. But whenever you will be substituting the temperature for estimation of specific volume, there it should be in Kelvin, because that is equation of state. So equation of state will satisfy only when temperature is in Kelvin. Other values, I think very simple, GTH etc. you can calculate. The major question was up to this point. So all of you have understood the concept of effective room sensible heat factor. Basically the idea is effectively how much sensible heat load is coming on the room. So that is some amount, because we have done the recirculation, ventilation, so that external amount which has bypassed, that comes as an additional direct load on the room. Is this point clear? And this is very simple way to calculate this question. If we do not know the effective room sensible heat factor, then what we need to do? We need to follow the iterations. Okay, that will be again a excessively complicated process. Okay, so we'll stop.